number, you could pull the number out. Same goes the other way. If the number's out front, you can push it up into the exponent. So what I did here was I took this -1 and I pushed it up as a power. So my next line would have gone like this. And when you're saying cosine x to the -1, that's the reciprocal of cosine, isn't it? That's 1 over cosine. And 1 over cosine is secant. Now the reason I'm showing this to you is because I don't want you to be caught off guard when you're sitting there trying to figure out why your answer doesn't look like the back of the book and they've done some crazy stuff like this. It's not crazy, but you've seen it now, right? It's a fair game. Here's one that gets students a lot also.
So for the test like that line, they're both right.
Yes. Yeah. How about this? Y equals natural log of 1 over x. If you were asked to take the derivative of this, okay, find y prime. Yes, that is the same thing as negative natural log of x. Now, let's try and do it without doing that first, okay? If I took the derivative of this, the derivative of this would be, derivative of natural log of u is 1 over u, right? That's 1 over u. It's 1 over whatever was in there, times the derivative of what's in here. So what is the derivative of 1 over x? So you're going to do quotient rule for me? You could, right? You could rewrite that as x to the -1 and take the derivative. That'd be negative x to the -2, wouldn't it, if I took that derivative?
Yeah.
And that's the same as -1 over x squared. So I did derivative of natural log of something was 1 over the something times -1 over x squared. What is 1 over 1 over x? What is 1 over 1 over x? It's right here. This is just x, right? That just reciprocates up. So you get just x here. X times -1 over x squared. What can you do there? This right here? I was doing the derivative, yeah, the derivative of what was in here. This is just, yeah, one of these x's cancels with one of them down there, and you get a -1 on top, and you just have a single x on the bottom, right? And that's it right there. That's your answer.
Or you could just have negative.
Or you could have first, before you took the derivative, rewrote the problem like this. That's the same thing, right? That's the same thing?
Yeah.
Then you could have used the property of logs that allows you to take a power and pull it out front. So if I pull that power out front, it becomes negative natural log x, right? See that property in action? The -1 drops out. Now I'm ready to take the derivative. If I take derivative of negative natural log x, the negative is like a -1. So it's going to come for the ride, right? So I'm going to cover it for a second. What's derivative of natural log of x? 1 over x. But then times negative. -1 over x. See how much easier that was to go from here to here? But it does work this way. All right, we got about 12 more minutes. you got to make sure you do the homework on this section. All right, this is out of the book, so I'm going to put it up here. This is a more challenging problem. Y is equal to natural log, there's a bracket there, natural log of 1 plus e to the x, but then all of that squared. Chain rule. Now, the reason why they put this in the book is to make sure you're not using properties incorrectly. I thought I just told you that if you had a power out here and you had a log that you could pull the power out. I did, right? That's what I said. Like we just did that on natural log of x to negative 1. I wrote it negative natural log x. That's because this negative 1 is a power on that x, right? And so then it can come out. The property said this, if you were to bring it back up. This exponent is being applied to that argument of the log, not the entire log. And here, this squared is actually being applied to the entire log. So you cannot drop that 2 out front. Do you see that? This would be chain rule. Now, here's what it would have taken for us to be able to drop the 2 out. No brackets. Then that squared would be implied to be on this. And then you could drop the 2. But that's not the way it is.
It's got to be on the, when you say the argument.
It's got to be on this argument right here. All right, so I'm going to use chain rule. 2 times all that stuff, right? All that stuff now to the first power. I don't need to write that, but I'm going to. Agreed? Times. I've done the squared. I move inside. What's the next layer inside? Natural log, right? So I'm going to take natural log of something. Derivative of that. So it's going to be, I'm doing derivative natural log of something that's 1 over whatever's here. 1 over 1 plus e to the x times the derivative of what's inside the natural log, which is, let's see, there's 2 terms here. So derivative of 1, 0 plus derivative e to the x is itself e to the x. That's it. Now I'm going to clean it up a little bit. Yeah, I'm going to put this e to the x on top, but this is also on top, isn't it? All this? So watch the way I write this. I'm going to write 2 e to the x times natural log of 1 plus e to the x all over 1 plus e to the x. So I just chose to put this e and this 1 and all this junk together. I put the e to the x right here after the 2. I dropped the brackets because that's to the first power, so that doesn't mean anything different. And then the bottom was 1 plus e to the x. Can I cancel these? No, because it's trapped inside the natural log, right? So you cannot cancel those. So that's it.
No, would you still accept the other one?
No. Got to clean them up now.
Okay, so how'd you get the 2 e to the x?
This, if you look at these as all fractions, right? Then
Okay, so
I just put that, I put this one, because of multiplication, I just put that right here. I took the brackets out, like that. See it?
Yeah, you can just go straight across.
Straight across. And on the bottom, same thing, straight across. All right. Last one for today. We're going to do more of this section next class. We are not done.
No, of course not. I like how you make that very clear.
Well, there's a major thing we still have to cover. So,
How far do you think we can make this?
do what?
How far can we make this?
You can make it all the way up through number 45. So quite a bit. I just I wouldn't do anything 52 and on tonight.
Quiz on Wednesday?
Quiz on Wednesday? Sure.
I was asking.
That's a request. That sounded like a request. I don't know. We're a little behind right now because I talked too much about the test in the beginning. It ate up a little time. So I don't know. We'll see. How about this? How about quiz grade on Wednesday? You have your homework on your desk beginning of class, and I'm going to just come around and look at it.
What, your homework
From this section. This is up through number 45.
Okay.
Okay? All right? Honest effort. I don't want to just see answers. I want to see work. All right. I want y double prime. I'm sorry. I don't. The book wants y double prime. Okay?
We're going to have to first find the right.
So you need first derivative first. So let's find the first derivative. And I heard quotient rule. I agree with that. But what? You want to bring the x squared up as a negative, like an x to the negative 2? You could do that. Then it would be a product rule.
Let's do that.
It's really up to.
Yeah.
I'm actually surprised to hear you say that. I mean, not a lot of students would voluntarily do that, but it's.
The quotient rule because of the square at the bottom.
You don't like the square at the bottom? All right. I'm going to do what you want here. Now, is it okay if I put the x to the negative 2 in front of the natural log? Is that all right with you if I do it that way?
Yeah.
That's still the same thing, right? Okay, so I'm just rewriting the problem, turning it into a product rule, and now we're ready for the derivative. So the first derivative will be, according to the product rule, you tell me, because you told me to move it there. Negative 2x to the negative 3 times the first plus derivative of natural log of x now, which is 1 over x, times the first one, which was x to the negative 2. Okay. You want to do the derivative again right now? So
Now, if you went.
Like, can you combine what would be easier to combine the x squared or the x to the negative squared with the negative 2x?
what would be easier is if we turned that into x to the negative 3 and then factored it out and created a new product. That's what would be easier. But can you see that? So I don't want to be robotic and just be like, I'm going to do product rule again now because I see product in another product. That would be correct. You could do that. But it's going to be a little bit easier is if I realize that first this is actually x to the negative 3. Because this is 1 over x squared. If I put it together with this one, it's 1 over x cubed, right? And 1 over x cubed is x to the negative 3. So I have negative 2x to the negative 3 times natural log x plus x to the negative 3. Now I could do the derivative now, right? I could do that and I'd have a product rule right there. And then this one would be a separate derivative, wouldn't it? Because it's addition. But I'm seeing that I have x to the negative 3 in both terms. So I'm going to factor it out. And what it would leave me with in here is, what would it leave me with in here? Negative 2 ln x plus 1. Do you all see that? If I distribute this back through, I get back this. I have not taken a second derivative. I'm just doing some algebra right now. Just cleaning it up because, I don't know, I've done too many of these that I saw this already. Like up here, I saw this. That's what I was talking about beginning of class when we were talking about reviews and practice. You don't get to the point where you see it until you've done enough of them. You can't, there's no such thing as doing too many problems in a class like this. And even the amount of problems in this book isn't enough.
So, had to make the answer be the product?
Yeah. There is one. Okay, so now I'm going to do product rule here. And the reason why I'm not intimidated by that, or like the reason I didn't avoid that, was because I know that this is going to be a pretty clean derivative. Then I rewrite this, big deal. The derivative of this is really clean, right? Because derivative of 1 is 0, and derivative of that, well, let's see what we get. So this is y prime. So y double prime will be derivative of the first one, which is negative 3x and negative 4 times this whole thing, negative 2 natural log x plus 1 plus the derivative of what's inside. So let's do this here. Negative 2 is a constant. It's going to come for the ride. Derivative of natural log of x is 1 over x. Derivative of 1 is 0. So negative 2 over x plus 0. So negative 2 over x times the first one. What was the first one? X to the negative 3.
And now you can combine the x to the negative 3 with the x, which would be
Good.
negative 2 to the negative 2x to the negative 4.
So negative 2, right? That's going to be minus 2. And then this is 1 over x cubed, and it joins this one, so x to the 4th on the bottom. Or could I write it a different way? Okay, you probably want me to do it that way instead. Because then you can factor it out again, right? It's here, and it's here. Let's go ahead and factor that out. I wonder how the book has this answer. When I do the homework solutions, the video, you'll see that when I was doing that, I was like, I wonder how the book's going to want that answer. I kept on flipping to the answer. I have the key for all the problems, and I was like having to tweak my answers to make it look like the book. That's pretty clean right there. You know, I like that version. But you could do, how about this? Could I do this? Could I do that? Right. This is really like an x to the 4th on the bottom. This is really an x to the 4th on the bottom side. The same denominator. I can put the two numerators together. Pardon?
It shouldn't be negative 3, not 3dx.
Where?
Or 3x.
Oh yeah, why did I put an x there? I don't know why I put an x there. It's not supposed to be there. It's just negative 3. And then I could distribute this negative 3 through. Right here and right here. So I could get something like 6 natural log x minus 3 minus 2. So when I pass that through, like that, over x to the 4th, I want you to try and make your answers look like the back of the book.
So many different ways to do it.
Yes, I agree. This was number was this? This was number 42. Let's just see. Oh, wow, I went over on time. I apologize. Okay, so everybody that's here picked up their tests, because I'm going to take attendance today off of these tests. These are the people who aren't here. All right, do your homework. That'll be a quiz grade on Wednesday. Have a good day.